Okay. Hi, my name is Nicole Diaz, and I will be presenting Capstone One Phase B Green Power Medical Ventilator Control Subsystem. We have the outline is subsystem trade study, subsystem architecture into components, trade study for critical components, subsystem risk assessment, control system, project planning. Now, the first options is open loop control system, non-feedback control system. And we can say the operational objective of this option is will control the devices using a feedback control system is a system whose output is controlled using a measurement as a feedback signal. The purpose of feedback control is to keep the control variable close to its set point. We can see in the control reference, um, we have the control action depends on output, no, sensitivity in less to external disturbances in system parameters, no. It can be used when inputs are not known, no. Number of components are less simple and cheap, yes. The optimization, no. The reliable and accurate, no. The second option, we have the closed loop control system, feedback control system. The we can say the operational objectives. This option will control the device using a feed forward control used to reduce the effect of measurable disturbances. This control take place before a process to make sure bad things do not happen in the first place, and the control identify actions to be taken before a problem occurs. The feedback control references control action depends on output, yes. Sensitivity in less to external disturbance in system parameter, yes. It can be used when inputs are no, no. Ahead of time, yes. Number of components are less simple and cheap, no. The optimization, yes. And the reliable and accurate, yes. For the third option, we have the sequential control. And the operational objective, this option will control the device using a sequence control. The sequence control governs the transition from one transaction to the next. Method of sequence control require explicit attention in interface design, and many published guidelines deal with this topic. In the sequential control references, we can see that depends on the generate feedback signal, yes. Need measurements of disturbances, no. All the disturbances are detected, no. It focus on the output of the system, yes. The variable are adjusted based on error, no. For the subsystem trade study, we can see we have the three options, the non-feedback, the feedback control, the sequential control. And the criteria, and wait, I'm gonna explain it that right now. We have the, for the quick reaction to blunders, 25, use a 12V power source, 20, stable signal frequency, 20, quick response time, so from 0 to 4 seconds, 18, and overshoot, 17, with a total of 100. We can see with the data we have of the three options that we mentioned, the we can see how this option, the non-feedback control system, is the option has a higher value, and it's the one that we'll be using. For the subsystem architecture into components hierarchy diagram, we split the control system into for the brain and electric. The brain turns the machine on and off, displays and manipulates some variables, and the electric energizes the device through a power source. In the interface requirement, the control system must provide a connection between the brain and electricity, and you must create a program that expresses all and allows you to manipulate variables. The number one, what programming languages should be used to connect to the Arduino to the electricity source. And three, create GUI that allows interaction with devices variables. The straight through study for the critical components and electrical selection, we have two options. We have the solar energy and electrical power with a battery. And the criteria and weight, we have the energy saver for 25, transportable 20, low cost 25, durability 14, and time of power without electricity 16, with a total of 100. With the data we have from these two options, we have the electrical power with a battery. We can see how this option again has a higher value and is the one that we'll be using. For trade study for critical components range selection, we have three options. We have the Raspberry Pi, the POC, and Arduino. In the criteria, low cost, we have 21. For the reset button, we have 22. Easy to use, we have 20. In the inputs and outputs, we have 12. And maximum supply, 20 for a total of 100. With this data of these three options that we have, we can see how the Arduino one is the option has a higher value and is the one that we will be using. For the subsystem risk assessment, we have the control subsystem list of risk. In the number one, uninterruptible force supplies don't turn off. I refer to the battery, and the two is the circuit broke links. The I refer to cables, and the three electrical misfortune for over 6 hours, and the four Arduino does not work. For the control subsystem list of mitigation strategies, we'll have an arrangement of correspondence to eliminate if has any harm. The two is utilize better material for the links or cables. In the three, uninterruptible for supplies will communicate something specific when it runs out of battery. And the four, the valve can be open manual, so we can fix it. We can see in the Sophia risk matrix how that affected. And now we have the project planning timeline, and that will be all for this presentation. Thank you for your attention.